1.4, Relating Polynomial Functions and Equations, Part 2. So last lesson we graphed using a table of values. It's not our best way to do this because you're kind of out in the dark. You're just kind of guessing. So we need some strategies to do it a little bit smarter. So we're going to start off the same way as we did before. So our degree, to figure out our degree, we're going to multiply all of our first terms. So we have x times x times x times x times 2x. So that's 1, 2, 3, 4, 5. So this is to the power of 5 is our degree. So it is a quintic. And our leading coefficient is 2, which makes it positive. So because it is an odd function, it's going to start in quadrant 3 and end in quadrant 1. So we're just going to imagine that. We know it's going to start here and end here. Okay, to find our intercept, we're going to our y-intercept, we're going to multiply all the back terms. So negative 1, 1, negative 2, 2, and 1. So negative 1, 1, negative 2, 2, and 1. And we would get 4. So that's our y-intercept. So we know it's going to cross over here at 4 in some point. Okay, now we can find our intercepts. So our intercepts is what makes each bracket 0. So these ones are really easy because the first one is just 1. The next one would be negative 1. Then it would be 2, negative 2. And the last one, if you're not sure what it is, when it's got a number in front of the x, set it equal to 0, and then you solve for x. So we have minus 1 from each side. Divide by 2, so x is actually negative a half. We're going to go negative 0.5. So we have an intercept here. We have an intercept at negative 1. And we have an intercept at negative 2. This is a very, very light sketch. We also have one at 1 and one at 2. So we know that this graph starts down here. It's going to go through this point, through this point, through this point, through this point, and up like this. So there is a very, very, very quick sketch of this graph, but it's probably fairly accurate. The only thing that we're not sure on is these maximums and minimums, how low they go and how high they go. And that's easy. We can do a table of values to make that a little bit more specific, which is a lot less work than making a table of values for a bunch of numbers. So let's do this. So we're going to graph this. We literally just did this one. Okay, so I'll write all that information down again. We already knew that the y-intercept was at 4. We knew our x-intercepts were at 1, negative 1, 2, negative 2, and negative 1/2. We know that it's going from quadrant 3 to quadrant 1. So let's sketch this a little bit nicer. I guess I got ahead of myself. Just so excited to graph that for you. Okay, let's go every 2 lines as 1. And let's make a quick table of values. So going back to here, we needed to find how low these points are. So we're going to look at, this would be negative 1.5. This one we could plug in maybe, you know what, it's good enough. We don't need one of those. Let's just do it. So if this is negative a half, no, it's so small in between those points, we don't need to worry about it. Let's worry about this one though. Let's go 0.5 and let's go 1.5. So we're going to plug in negative 1.5, 0.5, and 1.5. So I want you to pause the video and fill in that table of values. So what you should have got is negative 8.75, 5.625, and 4.375. So that gives us an idea. So we're going to plot all of our intercepts again. So we have one at negative 1, we have one at negative 2, we have one at negative a half, we have a y-intercept of 4, we have an intercept at 1, we have an intercept at 2. At negative 1.5, it's down at negative 8.75. So like way down here. And at 0.5, it's at 5.625. So it's up here, so it doesn't get that high. And then between 1 and 2, it goes to 4. 0.375. So like, I don't know, here. So graphing it, we're starting low. And I'm recognizing that I have these numbers backwards. This was at plus and this was at minus. Okay, this makes more sense. Okay, so this one is down here at negative 8.75. I was going to say it didn't make much sense. So down here, and at negative 1.5, it's up here at 4.35. So up here. There we go. Okay, so we're starting low. We hit up here. We go like this, down, and up. So it doesn't look very much different than this little sketch that I drew, aside from this part here goes higher than I guessed. So you can get a very good general idea of the shape without even doing a table of values. The table of values just makes it a little bit more accurate. And the more you do of these, the better you will get at visualizing that graph. Okay, so next one, it's not factored for us, so our first step is going to be, obviously, to factor. So we're going to take out an x first. So we have x squared plus x minus 6, and then we're going to factor this, so we need two numbers that add up to 1, multiply to get negative 6. Those numbers are 3 and negative 2. So our factors are x plus 3, x minus 2. So looking at this, our degree is 3, our leading coefficient is 1, which means it goes from quadrant 3 to quadrant 1, and it's a cubic. Our constant is 0, so that is our y-intercept, and our x-intercepts are 0, negative 3, and 2. And that is based off of our factored polynomial. So let's graph this puppy. Okay. Let's go every 2 lines is 1 on the x-axis. And we can go up by 1s on the y-axis. Okay, so let's start by plotting our intercepts. So I have an intercept at 0. I have an intercept at negative 3. And I have an intercept at 2. Because it's a cubic, it's going to start in this quadrant and end in this quadrant. So it looks like we're going to have one hill and one valley because we're going up then down. So let's write that down. That's what we call them. Hills and valleys. So let's make this a little bit more specific. So we're going to put in, let's go negative 1.5. It looks like it's halfway between these 2 points. And then let's go 1, because it looks like it's halfway between these 2 points. I also didn't plot this. Okay, so if we plug those into our calculator, we would get 7.875 and negative 4. So we can sketch that at 1.5 and almost 8 and 1 and negative 4. So our graph would look something like this. Again, it's a sketch, it's not perfect, but yep, there's your graph. You can check your answer by going on Desmos too. Alright, last one. Okay, we need to factor the last one. It's to the power of 4, so we're going to have to do some work here, some synthetic division. So let's plug in, let's try a 1, see if a 1 works. So 6 times 1 to the power of 4 minus 17 times 1 to the power of 3 plus 6 times 1 squared plus 17 times 1 minus 12. And this one does in fact work. So we're going to plug a 1 in here. We get a 6, negative 17, 6, 17, negative 12. Bring down the 6. 6 times 1 is 6. Add those together, we have negative 11. Negative 11 plus 6 is 5. Add those together. That's a negative 5. 17 minus 5 is 12. And we get 0. Awesome. So right now we have it factored to be x minus 1, 6x cubed minus 11x squared minus 5x plus 12. Okay, I want you to pause the video and I want you to figure out what the next term is going to be. What's the next factor? So I would try 1 again, see if that works, and go from there. Also, I don't know if this said this before, you can have the number work more than once, but if you find that it doesn't work, it's never going to work. So don't ever try it again. Okay, you should have found that negative 1 works. Minus 11 times negative 1 squared minus 5 times negative 1, that's supposed to be a 1, plus 12, and you should get 0. So we'll synthetic divide, this time with a negative 1. We have 6, negative 11, negative 5, 12. Bring down the 6. 6 times negative 1 is negative 6. Add those together to negative 17. Then this turns into positive 17, which we would get 12, making this negative 12 and 0. So our new factored term is x minus 1, x plus 1, 6x squared minus 17x plus 12. And for the sake of saving time for this video, I'm just going to factor this for you. You should be able to do that. Actually, you know what? Pause the video and factor it yourself, and I will give you the answer. I'm sure you actually paused it. I hope you did. If you didn't, you did not listen. But you should have gotten 2x minus 3 and 3x minus 4. Okay, so now that we have all of that information, we'll just quickly go over here. Our degree is 4. Our shape then is quartic. Our leading coefficient is 6, which means it goes from quadrant 2 to quadrant 1. Our y-intercept is negative 12, and our x-intercepts are 1, 1, negative 1, 3/2, and 4/3. So let's sketch that. Okay, so let's go every 4 lines is 1. That'll make it easier. Okay, and let's go by 2's on the y-axis. 2, 4, 6, 8, 12, 16, 20. Same on the bottom. Alright, so let's plot what we know. We know it's going from quadrant 2 to quadrant 1, so we'll just keep that in mind. The y-intercept is at negative 12, so I'm going to just plot my point there. And our intercepts are at 1, negative 1, 3 over 2, which is 1.5, and 4 over 3, which is 1 1/3. So that's really small. Okay. So what I know is it's going to go up, it's going to go down, and then it's going to have a little bump, bump, bump. So really what I need to know is what's happening in here, because that's kind of a big gap. So we're going to just make a quick table of values, And I'm going to plug in negative a half. And when I plug negative a half into my equation, I get negative 16.5. So it does get a little bit lower here. So our graph goes up, down, bump, 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 and then up again. So there's our sketch. It's fairly accurate. It is not perfect. Remember, it is a sketch. Okay, practice this. The more you do, the better it'll be to visualize, and we are going to be doing a lot of graphing in this course, and the better you are at this, the better life will be for you. Okay, XOXO Gossip Girl. Okay, so I got a little bit ahead of myself and didn't realize there was a whole nother page of lesson. So ignore my sign off and let's keep going. This lesson is long as heck. Okay, multiplicity means it has more than one time it touches an intercept. So that means that, for instance, this one, x plus 1, has a multiplicity of 4. So the way that it works is that if you have an even multiplicity, it's going to touch it but not cross the line. If you have an odd multiplicity like 1, for instance, it's going to cross it. The higher the multiplicities get, the wider it looks, like that or like that. That's terrible drawings. I'm sorry. I've really made a mess of this video. I hope you're learning. You're doing amazing. Okay, so for this one, our degree is 5. 4 here, and then 1 here. And our leading coefficient is 1, so it's positive. It goes from quadrant 3 to quadrant 1 because it is an odd function. So it's going from here to here. Our y-intercepts, let's find our y-intercept. So we have 1, but it's to the power of 4. So I'd go 1 to the power of 4 times negative 2. 1 to the power of 4 is obviously 1 times negative 2 is negative 2. So I have an intercept at negative 2. And our x-intercepts is at negative 1, and it has a multiplicity of 4. And then we also have x equals 2, which just has a multiplicity of 1, so we don't have to worry about that. Okay, so let's graph this. Let's go by 2. 2's not negative 2, negative 4. Pretty much always go up by 2's. I don't know. 12, 16, 20. And let's go every 4 lines is worth 1. Okay, so the way that this works is let's plot our y-intercept. What is our y-intercept again? Oh yeah, negative 2. So there's our y-intercept, and our x-intercepts are at 1, negative 1, and positive 2. So we know we're going from here to here. So this one, because it's an even multiplicity, it's going to come up, it's going to get really close, and then it's going to come down. We don't know how low it's going to get down here though, so let's make a quick table of values. I'm going to plug in a negative 1. When I plug a negative 1 into this equation, I get negative 16. So all the way down here at negative 16, and then it's going to go up. So there's the sketch of this function. Alright, last one. So let's find our first term. So we have negative 1 for the negative 1 in the front times x to the power of 3 times x. So we have negative x to the power of 4 is our first term. So our degree is 4, our leading coefficient is negative 1, so it is going down and it's even, something like that. So we're going quadrant 3 to quadrant 4. Let's find our y-intercept, so we're going to do negative 1 for our outside, don't forget the outside, times 1 to the power of 3 times negative 3. So our y-intercept will be at 3. Okay, x-intercepts. We have 1 at negative 1, and it has a multiplicity of 3. And we also have an intercept at 3. So let's graph this. Same as before. 4, 8, 12, 16, 20, -4, -8. That doesn't even look like a 4. -12, -16, -20. And let's go every 2 lines is worth 1 this time. And that's only because I see that that one intercepts at 3. Okay, so we're going to plot our y-intercept at 3. So right there. We know we're going from this quadrant to this quadrant. We have an x-intercept at -1. And we have an x-intercept at 3. So we know that because it's a multiplicity of 3, it's going to hug the line, but then it's going to cross it. Oops, that looks terrible. Hug the line, but then it's going to cross it. Now we don't know how big it's going to get in here, so let's try plugging in 1. Let's plug a 1 in, and I get 16. So I plug a 1 in, I get a 16, so it goes all the way up here. So this is what our graph will roughly look like. So again, those multiplicities just affect the behavior as it approaches the intercept. This is for reals the end now. Wait 1 second. This is for reals the end. I flipped the page. We're on to the next one. Last lesson of the unit. Okay, bye.